Okay, I think I got things going. We will see how it goes. Awesome. So with that in mind, let's get going. So last week I worked on, hold on. There we go. All right. Last week we worked on ARP, or as someone on YouTube kindly pointed out, it should be ARP. And we kind of went through getting that going, calling that as an extra function inside of the application so that we can get more information for about a host. Then we tried to move on to Nmap, and that didn't provide us with reliable information because it was a little bigger than of an application that I knew what to use. So kind of abandoned that. I was hoping to get time this last week to do a little more research. I think I got about 20 or 30 minutes total that I could actually do some research in on it, and I didn't get any farther, maybe not even 20 minutes. I didn't get any further than what we did in the video. So we're going to bypass that. And the other thing that was mentioned by the person on YouTube, it was a palindrome version of Noah. So thank you for the comments. I really do appreciate it. Is that network devices and the local computer will cache the information, and if they know it automatically, they'll go ahead and return it. So ARP is not or ARP is not necessarily a super reliable way to determine that a host is there outside of being able to ping, but it is a way to attempt it. And as we saw from our experience last week, we were able to get some results. Depends on how accurate they were. So with that in mind, this week, let's go ahead and take a look at some stuff. So vim source main. We have our function for getting IPs. This is the one that we built out using CIDR rules to be able to get our range of IPs that we want to do. Then we're trying to get our ARPA data by IP address, and we are returning back the specific information that we want. Then but when we're also pinging and returning back true or false. So in this case, we're getting string information back that we get the address. And here we're just saying, hey, the host is there or not. So if they have ICMP running, then we should get information back. Inside of all of that, we're getting the IPs and we're looping through. And we're printing out the result. So maybe later we can do some of the work with Nmap or whatever, but really let's reframe the goal of doing this. One is I just want to be able to see a few of the things on my network, and I want to be able to kind of try to figure out what's going on to see if there's any changes, and also learn more about networking at the programming level of everything. So since that's the goal, that is going to change. We're not going to do a super detailed like network scanner. Like there's a lot of good projects out there that do that. We are trying to do that, but at the same time, we're trying to learn about programming and network programming. So with that in mind, let's go ahead and erase the deck. Go. My yawning. All right. Okay, hold on, sorry. Okay. So one of the things, again, we're trying to learn Rust and we're trying to learn network programming. One of the ways that we can work with this is to be able to move these over to other files. Like I don't know how to like do a multi-file layout with Rust. So let's go ahead and figure that out first. Because I'd like to move that over. Then I can have an abstraction around trying to get these at a lower level, but I'm still returning the same result that my main application is looking for. So let's figure that out. All right. I have two have a main function and two other functions in Rust. One is ping host and the other is ARP data by IP. How do I move those each to their own files for better abstraction? Okay, yeah, I did mention it was in Rust. All right, let's see what we do. It's the general, yeah, you're smart. Yeah, I know that. So create module files. Firstly, you'll create separate files. Okay. And then use mod to declare the modules. Oh, interesting. Note on visibility, the pub. Okay. All right, interesting. All right, let's scroll back over the top. All right, splitting your REST code into multiple, that's just the normal ChatGPT. I'll guide you through moving ping host and ARP functions to their own files, assuming you have a project structure like this. Main RS. Yep. So first you'll create the other files, move the functions implementations to there. So you use the mod in the main RS, you'll now declare these files as modules using the mod keyword. You also need to use these functions by bringing them into scope using the use. Okay. Let's see. Oh, and then is the pub. Okay, yeah. No, the pub keyword makes your functions public, meaning you can access them from outside their modules. Without pub, the functions would, okay, so it's like in C++, you have your public and private methods. I mean, yeah, so I mean, it makes sense. Let's look at some organization. For larger projects, you might want to organize them in folders, subdirectories. In this case, mod.rs is the module for networking directory. And then you would do, okay, so you do the top level, then that thing, and then the file inside of that folder, and then the actual thing that you want to import in there. Makes total sense. This setup helps keep, yeah. Cool. Let's go and do that. All right. And all right. Yeah, let's go ahead and do that. Let's see. Make dir source. I think I like the idea of going ahead and doing that. Networking. Net source networking ping.rs. And then we're gonna copy this over here. And then we'll do mod networking. Then we'll do use networking ping host. Oh, did I? No, networking. I screwed it up. I screwed it up somewhere. My first time trying and I already screwed up. This is awesome. I love this. In networking, oh, I missed it. Okay. In networking, you need a mod RS. Okay, so this is like Python. In order to create a new library in Python, or in order to pull that in, you need your init.py. And so it looks like that is similar in Rust. You need your mod.rs. So let's create that. All right, now let's paste that. because we want ping host, file not found, file not found, ping host. I'm gonna do ping host. Yeah, that is not going well because it's named ping host here. And have mod rs and source networking. I spelled that correctly. Mod rs. Mod ping host. Use networking ping.r. I wonder if, well, I thought I tried that. Do ping here. Okay, so you bring in the file. Okay, so that makes total sense. So whatever the file name is that you want to bring in the module, and that'll work. And then let's go over here, IPv4. Let's just copy this for the moment. Whoops. There we go. Let's kill these. Boom. Okay, cool. That's in its own module. It's in the networking folder. All right. Sweet. And then we also are pulling it in here. And so now let's do this. Let's just double check our assumptions are working. So edit source networking arp.rs, do pub, yank, paste, okay. Is never used. Okay, right. So let's do use networking ARPA for D by. Okay, cool. All right, so let's go to here. We'll yank that or delete that and save that out. Whoops. Okay. All right. So based on the, oh, hold on. Let's delete this now. So based on this, let's leave get IPs alone for the moment. This should work. So cargo run. There we go. That worked. This is awesome. We're getting information back. Let's see, ARP data for host is incomplete. That's fine. We got a MAC address in there. Cool. So that actually wasn't too hard. So just to recap what we just learned, because it really was quite simple, is you create a folder, and however deep you want. Inside of each folder, you need a mod.rs file that brings in the module pubmod, the same name as the file. And so in this case, we have the file ping in networking, and we also have the ARP file or ARP file in networking, so that Rust knows to pull in from that. We set public in there so that we can use those functions in there. That's the kind of the difference with Python, is everything's public, whether you want it to be or not, for the most part. So that's where you kind of mix in some of the lower level C and other languages, because you're going to have private per module. So anyway, cool. I like it. That was actually quite simple. I, for some reason, expected it to be a lot harder. I guess because sometimes I run into problems with the environment and pulling in files when it comes to Python. Like you can sometimes easily mess it up and get yourself in a bad way. And so I was kind of thinking Rust would be a little more complicated, but I'm glad to see it wasn't. All right, so we have that moved over. Let us think about, well, actually, first, let's address how this is working, like how, like the result that we get. Because because it's kind of nasty. Like if it's not getting the data, then we're still, you know, printing something out. Or, sorry, it's not getting, all right, slow down, buddy. It's not getting a result that we want, and so therefore it's still printing things out. We're gonna make a change. So we have the idea that, no, let's not do that. I was gonna say let's make a change and assume that if you can ping it, then we'll get the ARP data. But I do like the idea of potentially finding a host with the ICMP protocol turned off, because I'm thinking like an IoT device of some sort. It might be, and they might default to having the ICMP just not even there, and so therefore you can't even ping it. But conceivably, you should be able to get the MAC address. You should be able to get ARP data off of it. And so I want to leave that option open. I'm not 100% on that concept because I'm still learning, but that's what I want to try. However, if I don't get back the data that I want, then I don't want to show it. So let's see what we can do. So what we did, let's look at the output. We have ARP data for host entries. Yeah, like this is crap. This is stupid. So here we have, so entry, interesting. So ARP for host entries is so just nothing. So because I'm doing a string extraction from a specific endpoint, then it's just getting the word that's there. It's probably something like there are no entries for this IP address. I'll bet you that's actually exactly what it's saying. Anyway, and then we're doing the IP address. So we already know what the IP address is because we're in that loop. So we do not need to worry about it. Really what we care about is that we're getting the MAC address. We don't want this. And so let's take an adventure and let's break open some Rust. What we're gonna do is source main. I'm gonna, out of curiosity, sweet, it worked. All right. So this is the command. It's doing its thing. We're getting the string back out. We're unwrapping each of the lines. We're unwrapping and we're getting the data. We're getting the second line because we have next. Then we are splitting based on the space. And then we're getting the third thing in there, and we're returning back the MAC address. Otherwise, we're returning back none if there is a problem. So I don't want to do that. What we want to do is we only want to return if there is a MAC address in there. So we could be naive about it and be like, hey, if there are colons in this, then return it back. Or we could do a regular expression check. I actually like the idea of the regular expression check because this is a kind of a known regular expression. Plus, we can see how to do some basic regex in Rust. So let's, whoops, crap. Okay, cut, paste. There we go. Okay, fix that. All right, so let's ask ChatGPT. Okay. In my Rust project, I am trying to get back a MAC address. Interesting idea. I will get to that here in a minute. I want to match a string based on a regex of a MAC address. How would I do that? So let's do it. All right, we need the regex crate. Makes sense, which provides for the regex. So let's go ahead and do that while it's finishing out its thing. So cargo add regex. Cool. Open that. All right. Use the regex crate to create a pattern to match the MAC address. A typical MAC address pattern looks like blah, where each pair of letters represents a hexadecimal byte. A regex pattern matching the MAC address could look like this. Okay. Here's an example of how to use the regex crate to match a MAC address string. Ooh. All right. So let's take this line by line, and I'm not going to read their description. I want to try to break it down myself. So we have our regex. Nice. We have our regex. We're importing our library. Let's not get ahead of ourselves. I don't like to write regexes, so I am going to trust ChatGPT. I mean, this looks right. Just looking at it. I mean, it is a little odd. Like, I hope it reads it, but the doing the 5 and then the I mean, I don't know that I've seen a MAC address like that before. I mean, it looks right. I mean, like, it doesn't seem outlandish. So then match MAC address pattern dot find. Okay, I like it. I like it. So let's do match MAC address pattern dot find data line. Yep, I knew that was going to work. So but we're not going to do that. We want to return a true or false. No, crap. No, we don't. We want to return the MAC. There's actually like 20 ways to do this. Okay, well, let's think it through. I'm kind of in this, like, let's just get it done, get it working, and not try to worry about like the right way. But I want to think this through a little bit. I don't want to be too cowboy on it. So let's think. So, okay. So this is gonna this returns back. Hold on. This should return back a result. Yeah, this turns back a result, and we're expecting to get it. Like, I don't. it's returning back true because you could have a bad regex. This also returns back a result. I know it turns like an option. Okay. Actually, that makes total sense. In here, I was splitting on a string. Oh, this is doing a thing. This is awesome. Okay. Okay. So this here is, I was splitting it, and if this isn't intentional, prefix it with underscore. Okay, let's not. Okay. So I'm getting distracted, buddy. All right, here I'm splitting it by the string and I'm getting the third result because I know that's where it come from. That is pretty brittle if they ever change. I doubt they'll ever change the output, so it's kind of a low risk, but it is kind of a risk. Let's take this, comment it out, we'll save, and then we got our regex. We're gonna match. So we're passing in a reference to the string, MAC address. So we want to do something with that. So we have our data line. Actually, I don't know what's going on here. Print line. Oh, let's do this. What? Oh. Okay, some data line, oh, so, okay. So this should be getting pattern mat returns the byte offset of the, yeah. So in the thing, we get the match, it gives us the start, then we're doing a range, we're getting the slice of the string to the end of the match, converting that all to a string, then we're returning it. Otherwise, you're returning none. So this should give us a MAC address always, whether there's one there or not. Okay, so let's go back to here. I want to remove, hold on, let's see. Okay, actually, this is awesome because now that we should be returning none more often, we should not be matching. It's not going to do anything. So it should only return back data that we expect and we want. So let's go ahead and cargo build. Let's run through that. All right, cargo run. There we go. Wait a minute. Interesting. Oh yeah. Okay, so I was printing out the result back, and it's giving me back the start at 21 and the end at 38, and so it's returning back the regex. Interesting that it is telling me these exist, but it's not getting ARP data. I like this. I mean, that makes total sense. See, that's cool. I like that. Let's go ahead and do that. So actually, there is kind of some neatness in what I did here. Is I kind of, through experience, I was like, hey, I want to print line this. It's kind of a debug thing. But I know I need to print out a reference to it and not the actual thing. And so I used a reference, and so therefore we didn't borrow for it, and therefore we could use it on the next line. I'm trying to get into used to dealing with the borrow checker. Still have some ways to go on that. So since this worked magnificently, we're going to delete that. So, and this is why I wanted to move it out here, so that we can do optimizations and still, you know, come out ahead. So yeah, see. So this is cool. So here we got information for one, but we can't ping it. So let's ping 192.168.42.11. But it did ping. Wait, right? Oh, I think I did the wrong one. 12. I think we did that one last week. Yeah, see, it's not pinging, but we were able to get ARP data for it. I think I keep saying ARP. I'm trying to get better at saying ARP, but I think I keep saying ARP. All right, let's see. All right, let's do. Sorry, I got distracted looking at my stream information. All right, to the person watching on Twitch, I appreciate you. I really do. Okay, so we have ARP go. Okay, we have ARP. Okay, we're not going to deal with that at the moment. Sorry, I'm trying to organize my thoughts and like the where I want to go next with this. Let's open up our main again. So we are consistently getting back the MAC address. We aren't doing anything if there's a none. We're in this loop, and there's like multiple directions. So let's lay out the directions that we can go. One, we can do Tokio for concurrency. This would be awesome because then I could spray out a lot of stuff simultaneously. We get a lot of results back really fast, and we'd be good to do. It would be good to go, like this would go a lot faster. I don't know why I just hit tab on that. 2 is save the information to SQLite. That's something I want to do. The next one we can do is you create CLI commands so that we can run this against CLI and actually get it. 4 is add whatever, what is it called? Notes about the hosts. 5, I don't want to ChatGPT or the Copilot really wants me to add a web interface, but I don't want to, so no. Then we could implement lower level packet stuff. We're gonna go with stuff. So those are the directions that we can take. Kind of tried to avoid the Tokio for a while. This is where the Japanese stuff in me is like, hey, is this meant to be Tokyo as in like the English Tokyo? Is this supposed to be Tokyo, like speaking Japanese, or is it Tokyo? Trying to say Tokyo because it looks like, people, it should be the English version of it. So I'm going to stop on that little rant, a little side trip. The other thing I want to do is better code organization. I got to start on it with the modules. And 7, better output. Yeah. So these are the directions that we want to go. What do we think would be a good first step? I feel like Tokyo might be a good way to go about it because we can abstract out and we can run the application faster. However, it adds a little bit of complexity for outputting the data in a good way, in a comprehensible way. The other issue that I just thought about is concurrently writing to SQLite. That might not be an issue. So you can only get one lock to write on a SQLite database. And if we're doing a fresh write, probably the first time you run this, it's probably going to try to have all the async code write to SQLite, and it's gonna like lock up and it's gonna be like, no, you are not allowed. However, I'll bet there's a defensive way to do that, of basically being like, hey, can I grab a lock? No, wait. Hey, can I grab a lock? No, wait. So we might explore that. That could be another interesting thing to work on in Rust. The next thing is, CLI commands. Really what we want for that is, add note on a host. See all hosts. See database information on hosts. Update and delete hosts. Yeah, that's all I can really think of for the CLI commands. I mean, it's not too complicated. So add notes about the hosts. I mean, that should kind of come before this. This is some of what we're after learning. I might put this one off just so that I can better research some of this, because I'm still trying to learn kind of out of band on this, so that I can have a better cohesive approach during this, and it's not all wild. And then better output, I feel like, is going to come whenever we create the CLI commands. So we did the other video on SQLite with Rust, and that was pretty easy. So you know what? Let's go for it. Let's do Tokio. Let's do it. Actually, first, let us take this information. No, actually, yeah. Let's do a little abstraction here. Then we'll go to Tokio. Let's see how far we get with this. Let's see what happens. Okay, so for each host, we want to do a thing. What information do we want to know? Let's think about this. Whoa. One, we want to know, is the host there? Two, if the host exists, what is the MAC address? Yes. And then three, we want to output in a good uniform way. So based on that, we actually want a struct host with the IP address, the MAC address, and the notes. I think this could be optional, because really we don't care about it for the most part. So what we want is so we want to actually, in all reality, this also needs to be, hold on, so it's going to turn a backup IPv4 address. Okay. All right. These need to be optional. strictly because wait, what am I doing? Option or optional? Okay. English versus code. Use angle brackets instead. Oh. My Python is showing. There we go. Okay, we don't want to put a dead code thing on there. All right. So now that we know this, we want to return, we want to get a vec of this data. All right, so let's be totally creative. There we go. For each IP in IPs, let host equals I think that works. Some IP. Yep. Fix that. This returns an option, which is what we want. And then this is a none because it's an option. And then we want to add that to the vec up here. And we want it mutable because we want the hosts. So we're calling, okay, I think that works. So let hosts equals get hosts. Before I delete this, and then let's do for host and hosts, blah, blah, blah. I think we're good. Let's run cargo build. Yep, it worked. Ping host was never called. I gotcha. I see what you did there. All right, let's run this for the moment. Let's cargo run. Dang, that was fast. Yeah, but that's pulling from a cat. I think we read somewhere last week that, or maybe I read it, that I think the ARP data is cached for 2 minutes. And so, yeah. But no, here, look at this. We have no data in some of these. So let's go back. We don't want to return anything at all. We don't want to add anything to the vector, if there is no data. So boom. All right. If not, if host is none, is some interesting. Returns true if the, okay. Is there an and? Host.mac, no, host.ip dot is some, and host.note.notes is some. Interesting. Actually, got caught up in the is some, and I'm like, that's actually not what we want. I mean, in this case, it would be an or, a row your boat gently down the stream. Or So, I mean, so it would be that. And so if any of those are true, then we would push. So the question is, do you check for the truthy of the situation or the falsy of the situation? Because it could be if it is none and none and none, whoops, none, then you would return back. You would actually do, actually you would just continue. Does there a continue? Yeah. Let's go back to actual Rust and not Python. Just out of curiosity, can you kill these? Oh, no. Okay. You never know sometimes. Like, it's just a language feature I was trying out. So, yeah, if all of them are false, then we just continue. We don't push. I like that a little better. Like, we're explicitly calling out, hey, if this is the case, then do a thing. And then all the other variations are fine after that. I kind of like that. So let's do this. Cargo run. Apparently that wasn't a good idea. Yeah, I have this function. How can I only want it to return a result if I only want it to return a vector of hosts if data is in at least one element of the struct. Man, I'm tired. And I'm like, not thinking, I can feel myself thinking slowly right now, but we're going to get through. We're going to make it. Data, one element of the struct. I only want it to return a vector of hosts if data is in at least one element of the struct. Otherwise, don't add that host to the vec to return. Your current function. No. However, the condition you're using to check this seems to be incorrect based on your description. You want to skip adding a host to a vector. Yes, I know it's incorrect. Here's a revised, thank you. Literally just had this conversation. Okay, I think this could be a Rust thing. Okay, let's... Okay, here's a revised version of your function that correctly implements the logic you described. Yeah. Like literally, we were like, hey, it's or, do the push, otherwise continue. I kind of liked the idea of saying like, if it's explicitly all false, then let's do the thing. But let's talk. All right, this code will now correctly skip or all none, given that IP is always some IP in your loop since you're iterating. Oh! Wait, what? No. Crap. I am totally stupid. I am totally stupid. I totally bungled that up to like 5,000. Okay. I'm not even going to read the rest of that because yeah. Okay. Basically, I will always have an IP address. Always. And so therefore, this check will never be none. Sorry. This check will never be none. It will always be some. So we don't want to check that. We want to remove IP address. I don't know why the highlight didn't work. So if Mac is none and notes is none, which is always guaranteed, the notes is always guaranteed, then we continue without adding. Yeah, I know it's not being used. All right. Okay, now let's run it. There we go. Just the pieces of information that we care about. We have MAC addresses. We don't have any of the superfluous information. There we go. Okay. Let's go ahead and delete this because we don't need it anymore. Let's do that. It's also super fast because I think it's pulling from the cache. It's probably also a little less heavy. Okay. Let us see. Host. Let's see. Let's do this. ICMP. Bool. No, I think we still want all right, thinking about it, if it can't no. I think it's still fine. Like, I don't know. This is where I would want a product manager if I was working on this thing, but since I'm the product manager, I think we're cool. Here's what we're going to do. This is going to be a Boolean value. In all likelihood, most of the time, if there's a MAC address, you will ICMP it. You will be able to ping it. And that's okay. So here's what we're going to do. We're going to do ICMP, ping the host, and we'll call it a day. And let's come down here. I think that's fine if it's never read. Let's do ICMP. Whoops. And then we want to do host.icmp. All right, let's do cargo run. It's got to do the build first. Oh, and it's actually running it because I think it's doing the ping. Wow. I feel like that's taking a long time. Oh. It's getting all of the data first, so it's going to run through it all. Then it's going to output it as it hits it. Yeah, so ICMP is true on all of them, but but 12 that we knew about and 26 are false. But there's something there. I wonder what, oh, look, 55. Really wonder what it is. Anyway. Cool. Let's go a little bit for, I mean, yeah. I mean, it makes sense why that was going longer now. Print. Total hosts. There we go. That's what I wanted. Whoops. Let's see. Let total host equals host.length. Total hosts. Cool. Let's run that. Oh, I meant to put a thing like, hey, starting. So yeah, so this has been interesting. I mean, we've gone through setting up modules. We've done some refactoring of our code. We've created a custom struct and set our information to it. We are iterating through. We got some experience, total host 32. So we got some experience on options and how it can bite you in the rear end whenever you're trying to check things. So that, I mean, that was a good experience. I liked that. I actually like failing in some of these instances because it helps you push forward and learn more. So that was awesome. I think we're good with that little note. I think that's fine. IPs. So that's, yeah, we're going through, we're getting it. Oh yeah. I wanted to put this. Print line. I want hello world. I want starting network scanning. Scanner. There we go. Boom. There we go. All right. I think we're good here. We're getting our hosts. And we're packaging it up in the struct like we want. We have the relevant information. So now we have a nice way to break it down so that if we want to get ARPA data later, we know, hey, we need to return back a string with the MAC address. We know that if we want to ping it, we can do ICMP. We can use the ICMP protocol directly. And we just know we need to return a true and false. For the most part, the rest of this application here is not going to care because at the end of the day, we're just getting hosts and we're printing them out. For right now, that's all we're doing. So I am excited. I think next week we are going to implement Tokio, and for concurrency, so that we can gather all of that data really quick, and then we'll see how fast that goes. Then we'll work on a better, deeper SQLite implementation so that we can add notes about this. I will work on figuring out like maybe what the data structure is that I want, or the table structure that I want for this. I mean, we're not going to go super advanced. I'm not going to use an ORM. We're just going to raw do SQL and tables because this is all about the learning. After that, probably going to do a CLI and do a little better code organization. Then we'll probably get to the lower level packet stuff in a couple of weeks. That gives me more time to research and understand and to potentially find anything else that I want to do. So I think this was a successful stream today. I think I learned a little more on setting up modules, got a little more experience. I think this went fairly well because I actually understand what all this code is doing. I have not, so an area that I still need to learn and I need to figure out like, hey, how can I hit this problem more is the borrow checker. I'm not really doing so. Like, let's take a look here. So in this case, like I'm getting information, I'm getting the host. And this is all pull. I'm pulling information from these other areas. I'm not passing the information in, doing something, and then pulling it back out. I'm pulling it from these other modules and combining it all together and then pulling it back up into the main. So since all of that information lived there and it's just sending it up the stack without doing anything, I'm not really dealing with the borrow checker right now. In this case here, I was, and so I, like just to kind of get it done real fast, I just set it here so I could call it later. So it's basically copying on here. Sorry. Yeah, so that is a big hole so far in Rust, but I feel like I'm getting a little more comfortable in kind of day-to-day Rust. So that is awesome. Yeah, I want to thank you for watching and tuning in, and check it out next week on the next live stream. In the meantime, you can visit me on Twitter or X at x.com/BuddyLindsay and give me a follow on there. And I will post a little bit about some of the other programming stuff, some of the Rust stuff I find, some of the other experiments that I do, talking about Vim a little bit, just kind of fun stuff. In the meantime, you can check this out after the fact on YouTube. It's kind of, from a Twitch perspective, it's the VOD, the video on demand. So with that, thank you, and I will see you next week. If I can figure out how to close this thing.